All right, good morning, guys. This is April 21st, and angles, just notes on angles. I do need to apologize for the past couple of days. Where I'm quarantining with my family, there is a Marine airfield 2 miles away from us, and these jets and helicopters are flying over the house and just shaking the house constantly. So yesterday and Monday, I decided, okay, I'm not going to do it because this is happening like literally every 10 minutes. You just kind of get used to it, but it is really counterproductive for making these videos. So they have slowed down a bit today. They're still flying. They're still buzzing the house. But if that happens, I'll just kind of be quiet and you'll just have to turn your sound down for a little bit. But I don't want to get any further behind on these videos. And I figured this will be a good time, if any, to not do the videos because this is the material that I gave out to you guys in the very first 2 weeks. I apologize for you seeing this again. However, the district has required us to give out the same material and to stay on track as a Math 2 PLT. So every Math 2 student is getting the same thing that you guys are getting. Originally, I was planning for us to just be out for 2 weeks, and I was giving you this material, and we would, cover the other stuff once we got to this. But I mistaken. This has turned into a lot more than just 2 weeks. So. Anyways, here we are, and we'll get started. So, angles. An angle is formed by two rays that share a common endpoint. And that common endpoint is called the vertex. For these notes, I'll kind of just fly through it. We do have another set of notes for the 22nd, and then we'll do practice on that. So, those rays are called the sides of an angle. So, you may obviously know all of this, but this is just kind of a good refresher for those of you who don't. And we always name an angle using three letters, A, B, C, or C, B, A. You can go either direction. And in certain cases, you can name it by just the vertex. So we can say angle B here by naming it just the vertex. But you cannot do that when you have multiple angles. So say I had something else here, and this over here was D. This was point D, and it had a ray as well. So now we have two different angles, and this will be 120 degrees. I can't just say vertex or angle B because now you don't know, am I talking about this one or am I talking about this one, right? So if you have an angle by itself, you can name it as just the vertex. But if you have multiple angles, we would have to either call this angle ABC or angle DBA, or you can, change that order just so that we can tell and denote the difference between them. So that's what they're saying here. Use a single letter if there's only one angle located at the vertex. And when for referring to the measure of an angle, we're going to use a lowercase m. So the measure of angle ABC is 60. And anytime you use the measure of something, the measure of an angle, you're always going to have a number, right? So we're talking about the measure of what that type of angle. So we have acute angles, which are less than 9 degrees. We have obtuse angles, which are greater than 90 degrees. We have right angles, which equal 90 degrees. And we have straight angles, which equal 180 degrees. You probably know all of those. Maybe straight was one that you forgot. But that's pretty elementary for stuff like that. So, example 1, name the vertex of this angle. This is K. The vertex is K. The two sides, you're going to use two letters for sides. You always use two letters for sides. So if I give you one letter, that's going to be either the angle or the vertex. If I give you two letters, that's going to be a side. If I give you three letters, that's going to be an angle. It has to be an angle. In the future, it'll be like a triangle and stuff like that too, but we're not going to worry about that right now. So give three ways to name the angle. We could call it angle K because the vertex is by itself. We could call it JKL. And we could call it LKJ. And then classify this angle. Anytime they say classify, we are using these types of angles right here. So classifying them, there's only going to be 4 choices. This one is obtuse. Same thing for example 2. I'm just going to kind of fly through this because this is pretty self-explanatory at this point. You can call it angle S, angle RST or angle TSR, and this is a right angle. So, congruent angles, if the measure of angle A is equal to the measure of angle B, then these angles are congruent. So this is written as angle A is congruent. It's an equal sign with a little squiggly line above it to angle B. So if you notice, the measures are equal because the measures are numbers, right? 75 is equal to 75, but the actual angles are congruent. The angles are congruent. The measures are equal. There's a little bit of a difference there. Oof. So an angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. It pretty much splits it in two. That's what we're talking about here. Two congruent angles, and that's what these little lines denote. I do want you guys to understand that there's not one line here. There are two separate ones, okay? In the diagram to the right, BD is that angle bisector. That's the ray. That's the angle bisector. Therefore, the two angles that are congruent are ABD, this first one, is congruent with angle DBC, the second one. All right, so they're congruent, their measures are equal. So perpendicular lines, two lines that intersect at a right angle. This is pretty elementary as well. And the symbol for perpendicular is an upside down T, right? So that T is a perpendicular intersection, right? So when we talk about lines, we usually denote them with cursive letters. So I would say that L and M are perpendicular. L is perpendicular to M. And we only know this because the box. We don't have the box, we don't know it. We can't assume it. I could do something like this and say, hey, does that look like 90 degrees? And you could say, yeah. And I say, no, it could be 89.9. We don't know it's 90 degrees unless they give me that box, okay? So from there, we'll keep moving forward to a perpendicular bisector. So perpendicular is the same thing. A line segment or ray perpendicular to another segment at its midpoint. So anytime you see bisector, it cuts it in half. Okay, a bisector cuts it in half. So this LM is a perpendicular bisector. It's a perpendicular line, and it bisects PQ in half. So in other words, from P to this midpoint, and from Q to that midpoint, it's the same. And that's what those tick mark means. Those tick marks denote congruency. All right, so in the diagram to the right, LM is the perpendicular bisector to PQ. LM is the bisector, it's the one doing the cutting. So in example 3, we'll just kind of like bring all this together to write another name for CBF. So we cannot say angle B because that angle B could be here, could be here, could be here, could be here, right? So we definitely cannot say angle B for this. We're going to go backwards and say angle FBC. That is another way to do it. To name the sides of EBD, you don't even need to look at the diagram. EB, BD, right? Because B, if it's in the middle, it has to be the vertex. To classify ABC, that is a straight line, so that is a straight angle. Give an example of an obtuse angle. Now there are tons. There's not just one example, but the first one that I see is ABF. There are plenty. All right, name two congruent angles. So we see congruency with the arcs right here. So those are two congruent angles, so we can call that angle EBA, and that is congruent to angle CBF. And then a perpendicular bisector, obviously we're looking for the box with the perpendicular mark. So there's our perpendicular mark. If you notice, AB and BC are congruent. So BD is the perpendicular bisector. BD is what is doing the cutting. So example 4, name the vertex of angle 2. The vertex of angle 2 is T. The sides of angle 4 is WT and TZ. Another name for angle 3, we cannot call it just T, right? But we can call it UTZ, like it's like the chip company. I'm sure you guys have been snacking a lot during quarantine. I know I have. Hoping to not come out of this 15 pounds heavier. Write another name for angle 1. So we can call that angle YTX. So classify, these are the 4 different types of angles. YTW would be a right angle. YTU would be obtuse. XTU would be acute. And WTX would be straight. 2 perpendicular lines. We see this box right here. It touches the 2 perpendicular lines. So we're going to say WX is perpendicular to YZ. And an angle bisector, something that cuts an angle in half. We see these 2 arcs right here. So TU is an angle bisector, and it cuts XTZ in half. There's your notes for angles, bisectors,